you step out of your spacecraft onto an alien world. How long do you have before you die? Today we're taking a deadly tour of our solar system to find out exactly how long you'd survive on each planet. No spacesuits, no protection, just you versus the most hostile environments in our cosmic neighborhood. The answer might surprise you. While some worlds will kill you instantly, others might give you precious hours or even days. But first, let's visit the places where your death would be so fast you wouldn't even realize what hit you. Jupiter looms before us, a swirling giant of gas and storms. You might think you'd gently float down through those beautiful cloud layers. You'd be wrong. The moment you approach Jupiter, you're facing gravity 2.5 times stronger than Earth's. Your 150-pound body now weighs 375 pounds. Your bones strain under the weight. Your heart struggles to pump blood upward. But that's just the beginning. Jupiter has no solid surface to land on. You're falling through layers of hydrogen and helium gas, deeper and deeper into crushing pressure. The atmospheric pressure increases rapidly as you descend. What starts as breathable air pressure quickly becomes like being squeezed in a vice. Your ribcage collapses. Your lungs are crushed flat. You're dead long before reaching whatever solid core might exist thousands of miles below. Saturn offers the same crushing fate, just with better ring views on your way down. These gas giants are beautiful from a distance, but up close they're compression death traps. Now let's visit the ice giants. Uranus and Neptune sit in the frozen outer reaches of our solar system where sunlight barely penetrates. Here you face a different kind of instant death. The temperature on these worlds drops to negative 300 degrees Fahrenheit. That's cold enough to freeze nitrogen solid. The moment you step onto these worlds, the cold hits you like a physical blow. Your exposed skin begins freezing immediately. Ice crystals form in your lungs with each breath. The methane-rich atmosphere is toxic, but you won't live long enough for poisoning to matter. Hypothermia sets in within seconds. Your blood slows, your heart stops, and you become a frozen statue in less than a minute. But if we're talking about instant death, nothing beats our sun. You wouldn't even make it to the surface. The sun's corona, its outer atmosphere, reaches temperatures of over 2 million degrees Fahrenheit. You'd be vaporized instantly, your atoms scattered into space before you could even register the heat. It's not death, it's complete molecular disintegration. Now let's slow things down and visit worlds where you might have precious seconds or even minutes to contemplate your fate. These are the rocky planets, and they kill you in fascinatingly different ways. Venus appears first, shrouded in thick yellow clouds. It looks almost Earth-like from space, but don't be fooled. Venus is hell with a planetary address. The surface temperature reaches 900 degrees Fahrenheit, hot enough to melt lead. The atmospheric pressure is 90 times stronger than Earth's, equivalent to being half a mile underwater. You step onto Venus and immediately face this crushing pressure. It's like being squeezed by an invisible giant. Your ears pop violently. Your sinuses feel like they're exploding, but the heat hits you even faster. 900 degrees is oven temperature. Your skin begins cooking immediately. You're literally being baked alive. The atmosphere around you is pure poison. Thick clouds of sulfuric acid rain down, burning any exposed flesh. You try to breathe, but you're inhaling superheated carbon dioxide mixed with acid vapor. Your lungs are seared from the inside. You have perhaps 15 seconds of useful consciousness before the combination of heat, pressure, and poison overwhelms your system. Death comes within a minute, but it feels like an eternity. Mars presents a completely different challenge. The red planet looks almost welcoming compared to Venus, with its rusty landscape and familiar day-night cycle. But Mars is a master of deception. The thin atmosphere contains almost no oxygen and creates virtually no pressure. It's almost like being in space itself. The moment you step onto Mars, your saliva begins to boil. Not from heat, but from the lack of pressure. This is called ebulism, and it's terrifying. The water in your soft tissues starts turning to vapor. Your tongue swells. Your skin puffs up like a balloon. You have about 15 seconds of useful consciousness before hypoxia kicks in. Meanwhile, the cold is working against you. Mars averages negative 80 degrees Fahrenheit. Without a thick atmosphere to hold heat, the cold cuts right through you. Hypothermia begins setting in, even as your blood is literally bubbling from pressure loss. You might survive 1 to 2 minutes total, but you'll be unconscious for most of it. Mercury offers you a choice of deaths depending on where you land. The planet closest to our Sun is a world of extreme temperature swings. The day side reaches 800 degrees Fahrenheit, while the night side plunges to -300 degrees. Land on the day side and you'll cook like on Venus, dying within seconds. Land on the night side and you'll freeze like on the ice giants, also dying within seconds. There's no winning on Mercury. But now we come to the surprising winners in our solar system survival challenge. These worlds won't kill you instantly. They'll give you time, precious time to think, to plan, maybe even to hope. Our moon takes first place in the survival Olympics. This might shock you considering the moon looks like a barren, airless wasteland. But those very features work in your favor. The moon has no atmosphere, which means no crushing pressure and no toxic gases. The low gravity 1/6 of Earth's actually helps you conserve energy and move around more easily. Your survival time depends entirely on where and when you land. The moon's day lasts 2 weeks, followed by 2 weeks of night. Land on the day side during lunar noon, and you'll face 250-degree heat. You'll overheat and die within an hour. But land on the night side, and you're looking at -250 degrees. Normally this would kill you quickly, but the lack of atmosphere means heat transfers much more slowly than on worlds with thick air. You could potentially survive for several hours on the lunar night side. Your body heat would slowly radiate away into space. But without wind or atmospheric convection, the cooling process is gradual. You'd eventually succumb to hypothermia, but you'd have hours to contemplate Earth hanging in the black sky above you. The real winner, though, might surprise you completely. It's not even a planet. Titan, Saturn's largest moon, offers the longest survival time in our solar system. This orange-colored world has a thick atmosphere, mostly nitrogen, just like Earth. The atmospheric pressure is actually slightly higher than Earth's, so no pressure problems. The temperature is cold, around -290 degrees Fahrenheit, but the thick atmosphere means heat loss is gradual rather than instant. Most remarkably, you could actually breathe the atmosphere if you had an oxygen supply. The pressure and gas mixture are close enough to Earth normal that you wouldn't need a pressure suit, just an oxygen mask and warm clothes. With proper preparation, you might survive for days on Titan. The thick atmosphere provides protection from radiation. The low gravity, even weaker than our moon, helps conserve energy. You'd eventually succumb to the cold, but Titan offers something no other world in our solar system can: time to actually explore and survive. Why do most worlds give you only 15 seconds of useful consciousness? This isn't coincidence, it's human physiology hitting hard limits. Whether it's lack of oxygen on Mars, crushing pressure on Venus, or extreme cold on Neptune, your brain needs a constant supply of oxygenated blood to function. When that supply is cut off or compromised, you have about 15 seconds before losing the ability to think clearly or take action. This 15-second rule appears throughout our solar system tour. It's the baseline for human survival in hostile environments. Some worlds kill you faster by destroying your body immediately. Others give you a few extra minutes as your body slowly shuts down. But that initial 15-second window of consciousness is remarkably consistent. Understanding these limits isn't just academic curiosity. As we plan missions to Mars and beyond, knowing exactly what kills humans and how quickly becomes crucial information. Every spacesuit, every habitat, every emergency protocol is designed around these harsh realities. The universe reveals a sobering truth through our planetary death tour. Of all the worlds in our solar system, only one allows humans to survive indefinitely. Earth isn't just our home, it's our only natural refuge in a cosmos designed to kill us. Every other destination, from our nearest neighbor Venus to distant Neptune, will end your life in timeframes measured in seconds, minutes, or at best hours. From 15 seconds on Mars to potentially days on Titan, your survival depends on 3 universal killers: pressure, temperature, and atmosphere. The universe isn't built for us, but understanding these deadly limits is the first step toward conquering them. Until we do, Earth remains the only world where you can step outside and simply breathe,